Welcome! This is training 3 for the science fair workshops. This presentation will cover making a research plan, understanding variables, and data collection. There are actually two options for activities for this workshop. I'll discuss both briefly in this video and then present another short video outlining those two activities. So this is the presentation for making your research plan, workshop number 3. As usual, you can start with your Science Rocks call out. And the overview for this workshop is to plan the research project, practice collecting data, and then hopefully there's enough time left for students to do a little bit of working on their own project ideas. So the point of this workshop is to get to be thinking more specifically about how to carry out a research project. So we've been up to this point talking about it in broad strokes and talking about ideas and research questions. Now we're going to talk about planning. So there are 3 big areas of planning and designing a project, groundwork, variables, and research design, and we're going to start with groundwork. So after you've decided on your question, borrowing from the second workshop, we're using the example of paper airplanes here. What style of paper airplane flies the farthest? You'll notice that this question is more specific. It gets at how we're going to test. We're going to look at type of airplane, and we're going to look at how far it flies, which is much better than our question from last week, which was very vague. Then we do background investigation. So an example for our airplane activity would be maybe looking up some questions about how does aerodynamics work, because obviously that's going to have a factor on how a plane flies. So this is some information that you might find out in your background investigation about how airplanes fly. And then step 3, we're following the scientific method here. The hypothesis that I had was that a dart-style plane would probably have the least resistance and thus fly farthest. So that's a little bit of background work, similar to our bread mold activity when we found out that store-bought bread has preservatives in it. So now we want to get thinking more specifically about our project, however, and thinking about variables. And your students may or may not know what variables are, so feel free to ask them. Has anybody ever heard of a variable? What do you think a variable is? Is there anything we can tell from the name variable? And of course, variable comes from vary. It means things that we can change, things that may change in our research design. And there are 3 kinds of variables we're going to talk about. So first is our outcome variable, which is also called a dependent variable. And this is what we're interested in measuring. So this is our outcome, as it's called, an outcome variable. So in this case, it will be how far our plane flies, and we will be measuring in meters, centimeters, inches, whatever's appropriate for your experiment. But it's good to specify beforehand what the outcome variable is and how you will be measuring it. Next is a change variable, and as the answer suggests, it measures change. So this is the variable in our equation that we're going to be shaking up. So in this case, for our airplane activity, it's going to be the design of the plane. So I propose trying a dart-style airplane, a swallow, and a tiger-style airplane. These are actually types. We have photocopies of different airplane types that we take when we do airplane activities. So these were the 3 most aerodynamic planes we had in our assortment, and these are the ones we're going to try and compare. And then last, we have what are called control variables. You may or may not have control variables in your activity, but the idea behind a control variable is that we want to keep everything the same except for the one thing that we're going to change. So it's really important to think about what are the things that can change that we don't want to change, and how can we go about controlling them. So in the example of our paper airplane activity, using the same kind of paper, using the same kind of throwing style, doing the test in the same locations, trying to control for things like weather, wind speed, these sorts of things. And maybe like if we had different people throwing the planes, we might want to do multiple trials and try averages or take the best throw, whatever we can do to sort of rule out all of the noise that might be introduced to a new experiment when we can't control what we're changing. So those are the 3 kinds of variables we want to think about in our research, and it's really important to try and make sure that we've considered all of these variables and that there aren't any secret change variables going on in our activity. And then we have the research design, which is just, in the case of science fair experiments, is a step-by-step plan for the experiment. So in the case of the airplane, I'll decide how I want to throw the planes. I'll practice my throwing style ahead of time to try and rule out any problems that might be caused because I'm not throwing consistently. I'll fold all of the plane styles from the same paper. I'm going to fly in an open, wind-free space that doesn't have any obstacles I might hit with my plane. I'm going to throw my first plane, measure the distance, write down the data, and then repeat for every step of plane. And as I said before, we might do multiple throws and average the distance, or we might do multiple throws and just take the best distance for each plane, and that's something that you need to decide ahead of time, so you're being consistent and you know that you're doing a good job on your experiment. Wow, there's some real spelling mistakes in this presentation that I will try to fix. So we're going to practice together designing an experiment. Now, this is your choice whether or not you want to break the kids into groups for this, or you just want to do it at the front of the room together. I like to do it all as a classroom together and just use like whatever whiteboard or something's handy to write things down with, just so everybody gets the idea. If you have older students, you might actually, we have worksheets for this that they can actually do, and then maybe they'll work on their own experiment, and then they can report out a little bit to the group when they're done doing a practice design. But if you want to do it with the group, which I do recommend is fun, really quickly, is the old Mentos and Coke experiment, which is really fun. So our question is, does adding more Mentos to Diet Coke make the geyser any higher? So as a group, we go through what's our outcome variable? What are we going to measure? They should pretty quickly realize that that's the height of the geyser. What are we going to change? What's the variable that we're going to alter from test to test? They should also pretty quickly get that that will be the Mentos. What are things that we're going to control? These can include things like how we add the Mentos to the Coke. It can be, controlling for location, definitely the type of soda we want to use. So another question we could ask, instead of how many Mentos, we could ask how different kinds of sodas respond. In that case, then our change variable would become the type of soda, and the things we'd want to keep the same would be the number of Mentos and the way we load the Mentos. And the kids are actually usually really good at coming up with lots of ideas of things that we want to control. So work that through as a group. And then, it's nice to do at the whiteboard at the front of the room. What are going to be our steps? What are we going to do for this activity? And how many times are we going to do it? And what are we going to do it with? So in the case of this one, you would expect to say, we're going to set up an area where it's easy to place the Mentos and Coke and it's easy to measure what's going on. Maybe we'll use a video camera, or maybe we'll have a spotter to spot the height of the geyser. Maybe we want to use some sort of tube. There are nice little Mentos and Coke tubes that make it a lot easier for you to drop your Mentos into the Coke with a pull string, and that eliminates the possibility of accidentally knocking the soda over, or not putting the Mentos in quickly enough, because there's all sorts of complications. This is also an activity it's really good to do a couple of tests on, maybe try a few Mentos and Coke explosions, geysers, and see what the problems may be before you do your final data collection. But write all those steps down, and then talk about, okay, we're going to add one Mento and see how high it goes. And then we're going to get a new bottle, and we're going to add 2 Mentos, and so forth. And we're going to write all that data down and chart it. So, what data are you going to collect? Well, obviously you're going to collect how many Mentos you put in, what kind of soda you used, how high the geyser went, and anything that happens. Did something weird happen, like you went to do your 5 Mentos, but before you could get the 5th one in, it sort of erupted? And this is pretty common with this activity, actually. Anything more than 4 or 5 Mentos is really hard to get into the soda bottle before it starts erupting, and it really doesn't have, I know from experience that it doesn't really have an impact. When you increase from 1 to 2 to 3 to 4, you definitely get a difference in your geyser, but after that you don't get much, and it actually becomes kind of challenging to get any more Mentos in the soda after that. But think about that. And what should your data table look like? So we're going to be taking these measurements down. What should it look like? And you can actually draw the Mentos and Coke table up on the board based on the feedback from the students. This is an example of a data table for our airplane activity, so we might just list the type of plane, the distance flown, and any notes that we have about it. You could take other data like the time that it flew, but for our question that we were talking about before, that's not really relevant. So that's another question is, obviously, as scientists, we'd like more data, but sometimes we're just taking superfluous data that's not really helping us answer our question. So maybe in the interest of time, we don't want to do that, but we might. It might help us with a future question. So we're going to build a table together here. That actually, I skipped ahead before. You can build the table for the Mentos and Coke there or not. There are some rules for good data collection, which include that anyone should be able to look at your data and understand what it means. Collect all the data that you might need. Collect the right data. So if we're trying to measure distance and we collect time but not distance, that's no good for us. And then that's the really quick presentation portion of the first part of the presentation. Then there's an activity around data collection.